What's up? I'm Jacob Blitzo, your Elixir mentor. Today we are going to be talking about web application security. Paraxial.io, a Elixir security platform, sponsored this video. Paraxial.io offers a comprehensive security suite tailored for Elixir-based applications, filling a critical gap in protecting these apps from cyber threats. It provides tools ranging from asset management to runtime exploit protection, making it an essential platform for Elixir developers to ensure that their applications are secure and resilient in today's digital landscape. Why would you need something like this? Maybe you're thinking you aren't high profile enough to succumb to an attack. Unfortunately, this day and age, there are malicious bad guys or hackers out there that are automatically searching and looking for web application vulnerabilities. So if you can access your web app from the internet, you are vulnerable. You may remember the Equifax data breach in 2017. This was a high-profile breach where sensitive personal data of nearly 147 million individuals were exposed. This led to Equifax paying $425 million in a settlement. The cause was a vulnerability in Apache Struts, a Java web framework similar in function to Elixir's Phoenix. Equifax failed to identify and update the vulnerable version of Apache Struts in time, leading to the exploit. This breach underscores the importance of asset management and the need for proactive security measures like those offered by Paraxial.io to identify and mitigate vulnerabilities before they can be exploited. Asset management is a critical but often overlooked part of companies' security strategies. It's essential for maintaining awareness and control over assets. Many companies lack a robust system, leading to vulnerabilities, as not knowing your assets is like leaving doors unlocked. Particularly with Elixir and its dependencies, tracking versions is vital to avoid exposing applications to known security threats, much like driving a car without checking for recalls or maintenance needs. Paraxial.io offers a comprehensive summary of your Elixir applications. Along with their security status, you can check the information. You can see each environment. So you can see that development, staging, production, local. In this case, I have a local and production environment. And you can also see which ones are publicly accessible to the internet by this web facing. So you can see local is false, and then the production version is true. And you can also see that the latest security findings from the centralized dashboard here. So you can see that my local version has a bunch of critical, high priority, down the line vulnerabilities. And if we go ahead and click into this, so you see that we have the asset manager, the compile time scanning of vulnerabilities. You can see that we have 9. And then a unique feature called Exploit Guard. And this is all part of what Paraxial calls application secure on the left side here. Now, asset management not only lists your assets. So right now you can see that this app is currently running Elixir 1.15, and we're using Phoenix 1.6.16, and then Paraxial we're using 2.6.3. But you can also see we have 78 total dependencies or assets. And if we want to actually see that list, we can click on App Audit here. First it tells you, over time, if you've added or got rid of dependencies, right? And what's nice here is it gives us a full list of every dependency in this project with its version number and the details of the dependency. So just one quick site, you can see how many dependencies your web apps are using, and it's really handy staying on top of versions and just knowing. So if you hear about a vulnerability that is in a library that you use, you can quickly come here, see that you have it, and maybe get it updated before it even becomes an issue. So that's pretty cool. And then if we jump back to the dashboard where we can see our vulnerabilities. So this is compile time scanning, where Paraxial actually scans our entire code base and looks for vulnerabilities. And we can go ahead and go into code scans on the left side. And this breaks down a detailed list of every vulnerability in our app. So you can see we have some critical and high severity ones, which are really dangerous. What's cool though is we can just expand this, and it explains to us what it is. So what is a SQL injection? It tells us, and then it also tells us what we're doing wrong and how to fix it. So that's pretty freaking cool. So we can go through all these vulnerabilities and fix them before it hits production. And then the last thing on the left application secure side is Exploit Guard. And Exploit Guard can detect and block attacks in real time, even if your app is already vulnerable, providing an essential safety net. Basically, it monitors or will kill the Erlang process to block the exploit that are currently available in your app. So this can be super dangerous, where people can actually execute nasty code through vulnerabilities, maybe in a form or some sort of input, or maybe just a vulnerable dependency. So if we just quickly compile, let's go into an IAX shell here of our app. So IAX space -S mix, and it's going to boot up our app and all of that good stuff. So the example that I'm about to show you is going to just demonstrate a security risk using binary to term for deserializing binary data in an Elixir application. The exploit function is going to open up our calculator app. Like, it's not going to do anything malicious. Obviously, we don't want it to do that. So I just created a anonymous function here that just opens our calculator. And then if I hit enter, we can see this by typing in exploit dot and then calling our anonymous function, which takes 2 arguments. They can be anything. And when I hit enter, it opens our calculator, which isn't a dangerous thing. Like, we know what this command does. But when we turn this into binary and then we use base.encode to make this a string, we can, when binary to term is used again, it can actually regain, or it retains its ability to execute the original command. So in practice, if an application unsafely deserializes user supplied data, this is a way it could inadvertently run potentially harmful code on your server. Now what I'm going to do is I'm going to take this function, and basically we're just going to turn it into a binary represented in a string. So there we go. It's just a string. So this could be passed in any form, any of that, right? And now when I go ahead and I'm going to just set this equal to a function, when I use binary to term and pass in this payload, which is just a string, we're passing it in right here. When I hit enter, that string turns into this executable code again. So if I hit F dot, and then we can go ahead and run this function. So that string just was turned back into a anonymous function that could potentially run nasty code, right? All right, so I'm gonna quit that calculator. Now, the exploit, the exploit guard is really freaking cool. One thing I want to do real quick, we're going to close out of the shell because we have to recompile our compile settings. But what I can do here is in the Paraxial settings, I can enable exploit guard. So what this is going to do is Paraxial actually has the ability to scan for potentially harmful code that could pose a security threat. So when this is enabled, we are going to get a Slack notification. So Paraxial has an awesome Slack app that you can just integrate into your Slack workspace. So when this is on, just monitor gives us an alert. If it was on block, it would actually block the IP that ran this code, but we don't need to do that right now. I just want to show you that you can be very well aware of any nasty exploits being used against you on your own code base. So let's boot up our shell again, IAX space -S mix. And what we'll do here is we're going to do the same exact thing. So we're going to create our exploit, which opens the calculator. And then we're going to convert that function into a binary string. And then when we run this nasty code inside of our project, Paraxial actually does its job and it detected this. So now if we find our app, now you can see I have 2 new messages, and exploit guard alert hit my Slack channel. And it told me that binary to term created a new function at runtime, meaning the attacker is running remote code execution exploit against this site. So there is no response. It was just in monitor mode, but it's really cool. It tells you how you can fix this. So it gives you everything you need to know. And if we automatically blocked them, it would just show up in a ban list. And I'll show you that in a second when we set up some rules and everything too. This is really cool. It told us that this exploit happened in real time, which is pretty powerful. You wouldn't normally know that this stuff is happening to you. So this is cool. Now, I did fix all those vulnerabilities off camera because it just isn't that important. You just go through the steps and it tells you how to fix it. And I fixed them. And now we have 0 vulnerabilities. Paraxial.io integrates code scanning to identify vulnerabilities your Elixir code and dependencies have. And it prioritizes them based on severity, which we saw. And then it gives you guidance how to fix them, which makes it a viable tool for maintaining code health. So let's look at how this works using Paraxial's GitHub App Integration. So I already prepared some code with vulnerabilities, and I'm going to push it to GitHub. And then we're going to walk through creating a pull request and seeing how Paraxial.io flags vulnerabilities. So if I go, we're going to just exit out of the shell here. And I'm going to say git check out. I think it was add vendors. All right. So I have this code here and it's a PR with a couple files changed. I'm going to go ahead and push this to my GitHub. Git push origin add vendors. And there we go. Now if we jump over to my GitHub repo, we can see that I just pushed. So now I have a branch here, add vendors. And I'm going to go ahead and create a new pull request and make sure that you don't put it into the fork. We're going to merge it into our master. And now when I go ahead and hit create pull request, we're going to sit here. And as you can see, Paraxial.io is now going through and running its live scan. All right, now the scan is done and it came back with an error. So we could hit details here and it shows us that an error happened in its automated build and test phase. But what we want to go back to is it actually created a comment above. So how cool is this? If we scroll up a little bit, you see that Paraxial made a comment, a critical vulnerability was found, and look at that, binary to term is being used. And you can say, well, what is this? It explains it to us. And then you can say, well, how do I fix these issues? And you can go through all this stuff and it really educates you. And it also gives an example of, look, the Equifax. This is a vulnerability that you could run into with using binary to term, right? And then if you scroll down more, Paraxial.io bot or the GitHub app actually makes a suggestion for us to fix it. And the safe fix is using plug.crypto.non-executable binary to term. And I don't even have to go back to my code base. I can literally just say commit this suggestion and commit changes. And now our code, it'll do the Paraxial scan again, but it's automatically, it suggested a fix. I took the fix and now we'll wait on the scan. All right, so the scan finished and Paraxial made another comment. This time, no issues were found. And this is a scan for our production app. So this is important. And look, now we have all green check marks and we're good to merge it. So confirm merge, and now we don't have vulnerable code in our code base. Paraxial caught it, which I think is pretty awesome. So if we go back to the dashboard and go into our production, so you can see that we have 76 libraries or dependencies and 0 vulnerabilities, and no exploits have happened on our production app, which is good to see, right? A very recent example is the 23andMe data breach, and that just happened. So this breach was carried out using a technique known as credential stuffing, where attackers use leaked usernames and passwords from other breaches to gain unauthorized access. So unlike the Equifax breach, this didn't involve compromising the underlying web server or exploiting a direct vulnerability in the web application. Instead, it leveraged weak or reused user credentials. This incident highlights the need for robust defense against bot attacks and credential stuffing attempts. Paraxial.io offers a sophisticated bot defense mechanism. This feature includes IP rate limiting, detailed context on blocked IPs, and innovative techniques like hidden forms to identify and block bots, also known as honeypots. So on the right side is where you'll see your traffic analysis and, any IP limiting and things like that. And right now you can see there have been 3 requests to our production server, 0 blocked. There is 1 active rule, and it actually looks like login attempts got banned. So if we go over, we can look at traffic analysis, which is really cool. You can see when the allowed things are happening, how many different IP addresses were used, allowed and total requests, and then blocked requests. And you can see what paths were used. And then you can also see rule events, and you can see that the path users.login led to a ban. And if we go to rules, you can see that our login attempts, we have a rule set up. If there are 5 requests within 20 seconds, we're automatically banning that IP address. And you put the request path here, and for us it's users/login and the HTTP type, which is a post. And what this does is if we go to our live app, this is our live app here, and this is just the Potion Shop. It's an open source, and it comes with vulnerabilities, so you can actually test this stuff with if you're not using Paraxial, you can use like Soblo or other things like that. But when I go to log in, you can see the path here, all right? And we can log in like normal here. So if I do Jacob at elixirmentor.com and then my password, there we go. I'm logged in. Now, since we have a rule already established in our dashboard, if I hit that endpoint, let's see if the rules, if I hit that endpoint 5 times in 20 seconds without successfully logging in, I'm going to get my IP blocked. And I'm also going to get another Slack channel alert, which is really sweet. Now I have a secret little script here that I'm going to run. Okay, so I'm going to run this script now that is going to demonstrate our rule has been in place, and it's going to automatically block me. And what this does is it's just going to send 10 different credentials to our login endpoint, but they all come from the same IP address. So Paraxial knows that it's obviously malicious behavior because we've just tried to log in 5 times in 20 seconds. So when I hit enter, I'm automatically blocked here, okay? All right, so now that we're blocked, if we jump over to our Slack, you'll see we got a new alert from our bot defense alert for a rule match. And it tells you what site it's on, which is our prod Potion. And then it tells you that it was for login attempts, 5 requests in 20 seconds to our user's login path. And then it tells you the IP address of the violator. So that's really cool. But if we come to the dashboard and I'm going to refresh it, We now see that login attempts banned 6 seconds ago, and there is one on the ban list, and we've had 12 blocked requests. That's pretty cool. And now when I go to the rule events, you're going to see, so the 23 seconds ago was the one I just did, and you're going to see my IP address here for the user login. And so I am officially banned. And now I'm on the ban list too. You'll see my IP address here. And this is for login attempts matched. And it gives you the date. And now you can also edit these. So if this was a mistake, you can remove it. You can also permanently add IPs to an allow list so they never get banned, which is pretty cool. And then if we go to the HTTP tail on the side here, you can see all the posts and endpoints and gets that have happened, and the error code 429, 200, whatever they may be. You can see every endpoint hit for your web application. So I think it's pretty cool. It gives you a ton of power, and you can make rules for any endpoint so you can protect everything. Paraxial.io provides a complete security solution for Elixir applications, allowing you to easily monitor their security status across various environments, such as local, staging, and production. The solution seamlessly integrates with GitHub to prevent any vulnerable code from entering your application. Moreover, it sends instant notifications on Slack for exploits and bot defense alerts, ensuring the security of your web application. With Paraxial.io, you can be assured that your web application remains secure, giving you peace of mind. If you want to learn more or you are interested in using Paraxial.io, check out the link in the description below. Join my Discord server, Elixir Mentor, if you have any questions or just want to hang out and chat. That link is in the description as well. If you want to learn how to build scalable, production-ready API and full-stack solutions, hit that subscribe button now. I'm Jacob Blitzo, your Elixir Mentor. See you in the next video.